very frustrating. Bigger profit margin there.
There you go. Supply and demand. Revolves around.
Yeah. All right. Let's get to R2. So the way I'm going to work R2 is, again, because it's review, I'm not presenting this like, hi, this is the first time you've ever seen this topic. So the way I'm going to do it is I'm just going to go directly to the homework problems that you have, and I'm going to just pick some problems right next to your homework problems that are very similar to what you're going to be asked to do at home. Make sense? So like you're asked to do number 26, and I'm going to do number 27. All right? I'm going to do that for as many of these as I can until the end of class. And that way you can go home. You'll have your homework assignment out of the book, which again is on the schedule. All right? The homework assignment's in here. And then you have the assessment. The assessment by far is the most important thing for you to worry about right now. All right? If you have to use all your time for the assessment and don't get to the homework, don't worry about that for Thursday. But have it at least done by next week. All right, so the first problem, number 27, out of the book, this is an R2, number 27. It says to write as an inequality. And it gives you a sentence. It says x is less than 2. Now, let's not make this harder than it has to be, all right? How do we write that? In mathematics, in mathematical symbols, how do we write x is less than 2?
X.
Okay, x. And then
Alligator mouth.
alligator mouth,
Eating to the right.
eating to the right. Okay, I like that. Then 2. So the alligator always opens up to the bigger number? Okay. Or points towards the smaller number? This, right. That's the way we write that mathematically? This right here is called an inequality symbol. How many inequality symbols are there?
5, 1.
There's 4. There's this one, that one, and that one, right? This one would mean the left side is bigger than the right side. This would mean the left side is smaller than the right side. This would mean the left side is bigger than or equal to. So would this be true? Is that a true statement? Is 4 bigger than or equal to 4? Yes. Would this be a true statement? 4 is bigger than 4? No, that would not be true. So these we call strict inequality, meaning that they cannot be equal. But these, when you include the bar on the bottom, means you could have equality. All right? This is x is less than 2. Now, on a number line, just so you see it, if we draw a number line, here's 2. X being less than 2 means x could be anything over here, couldn't it? Anything. Forever. That direction.
It can't be 2 or anything.
But it can't be 2 or bigger. So a lot of times what we'll do is we'll kind of like shade this part of the number line in. And then we'll put either like an open circle here, or we'll put a parenthesis. And it depends on the book. You might see that, or you might see an open circle there like that. Pardon? I think it's 27. Is that not 27 years? Yes. What version of the book do you have? Yeah? Are you in R2, page 27?
No wonder why.
Question, yes.
Sorry. Sorry to interrupt, but
No, it's okay.
would the next be negative infinity?
Where what?
And just exit, so, like, because
It goes forever, right? Okay, look. This statement, x is less than 2, means x can take on any value as long as you promise me it's less than 2. So would 0 suffice? If I said x is 0, would this be true? Is 0 less than 2? Yes. But so would negative 1. Negative 1 would work. Negative infinity, though, okay, is not a number. Negative infinity is an idea. All right, it's a concept. Infinity is the idea of something that grows without bound. All right? Thank you for asking. I have a feeling we're going to get some good questions from you. Yes? I hope to answer them. I enjoy curiosity. Okay, how about this one? Let's change it up here a little bit. Oh, I like to give this one to college algebra students. So I want everyone to kind of jot this one down. I want you to figure out what the answer is. Don't say anything. I'm going to take a vote, and we're going to see who gets this one. I'm going to go back to the old school notation. So 12 divided by 3 times 4. Everyone ready? Have a potential answer? All right. So let's take a volunteer to give me an answer.
I'll be the first to jump into the pit.
Jump in?
1.
Okay. 1 is the first proposed answer. Any others? 16? 16? Any others? Good. Those should be the only two I hear. 73? We're going to go ahead and do that triage right now. All right. I think it's obvious to everyone that there are two ways that you could have. Does everyone see? Well, we didn't vote. Ones. Okay. 16s. Oh, we got about half. It looks right around in the halfway point. Interesting. So, for those of you who answered 1, do you see how you could have got 16?
Yes.
Does everyone who answered 16, do you see how you could have got 1? Okay, so I think both answers are reasonable, but only one of them is correct. So the one that is correct, 16. Now, the bigger question is why, right? What's left to right? I do this from left to right. So a lot of people who got 1 were probably using this. How many of you who got 1 used that, PEMDAS, which stood for, did anyone give you like a little saying for it?
Yeah, please excuse my dear Aunt Sally.
So that one, they're still using that one, huh? Aunt Sally's still around. Okay, please excuse my dear Aunt Sally. The problem with teaching this, and I was very pissed when I saw this the first time because my math teacher didn't show me this the right way. I thought that multiplication and division were in that order, multiplication then division.
But it's multiplication and division at the same time.
That's right, it's multiplication or division.
Left to right.
It's from left to right. So these are actually clumped together and these are clumped together. And it's always left to right in the expression. And that's the same thing for addition and subtraction, left to right. And that's quite upsetting because that's not the way I was taught. So I was at a disadvantage there. The correct answer is 16. So if you got 1 because you followed this, you're not wrong, you were just shown incorrectly. Or maybe you don't remember it correctly, I can't say. But
That's why you enjoy asking college algebra students this.
I enjoy it because there's someone sitting in here who probably knows how to do everything I've done today, but still learn something today that's going to benefit them. Okay? That's why I do not enjoy humiliating people. I'm not trying to do that. But if now you know this, good. That works.
The first time I actually got 1, then I was like, you're an idiot. Or it's just left to right.
Okay, you said that. I don't think that you would be an idiot for doing it and getting either answer.
I was just saying that to myself. I was like, because I was overcomplicating it.
Okay, if you don't get 73, I think you're pretty good off.
Yeah, I think if you got if you got the answer was blue, then we could use the word idiot maybe, but even then that's. All right, so this is the correct order. All right, let's move on. We got to get to something else. Another set of. I saw something on that last night. Actually, I was watching a video on converting pictures into sound. It was pretty interesting.
That is actually pretty interesting.
All right, so classic problem here. -3 squared. 9? Shall we vote again?
Is it green?
It's green, yes. Okay, how many of you go for 9? I'm hearing 9. Any other answers potentially?
I would say -9.
Negative 9 because there's no parentheses? Could be. Hey. I'm glad that someone said -9 because -9 is correct. Okay, no, hold on. We have to understand why. So let me put this versus like there's a battle here. Okay, versus this expression. This shows you the importance of the use of parentheses in an expression. We don't just use parentheses because we enjoy them. We're like, it'll just look prettier if we put parentheses around it. There's always a reason for parentheses in mathematics. I know that a lot of times early on in math, people are uncomfortable with parentheses, so they just like put them just to be safe. It's like, I'm just going to be safe. I'm not sure if they're supposed to be parentheses, so I'm going to put them. I was the same way. It's like, I just put them. But it changes everything, okay? What this means is exactly what squaring something means. You take -3 and you multiply it times itself, right? Yeah. -3 times -3. And we know that negative times negative is positive, right? So this is positive 9. The other one, on the other hand, really looks like this. That's really what that means. Because a negative sitting out in front of something is like a -1. And now look at your, please excuse my dear Aunt Sally, which I think some of you probably are a little skeptical with now. Just remember these are clumped and these are clumped.
Aunt Sally lied to us.
Yes. So what is done first? Parentheses? Well, in here we don't have parentheses. Then you do exponents. So you got to do the 3 squared first. You don't do the -1 times the 3 because that's multiplication, right? So you do 3 squared, that's 9. -1 times 9 is -9. How about this one? I'll put it up here next to these because it kind of looks the same. What's that? So how about this? -1 times 3 to the -2. Do you agree with that?
Yeah.
All right. What does raising something to a negative power really mean? So let's see, if I put this property up here, maybe you'll remember it. Do you remember seeing this before? X to the -n equals 1 over x to the positive n. This is a property of exponents. Trying to see which page they're on. If you look at this section, R2, look through here. They have all the different rules of exponents in here. You might want to go back and review them if you haven't seen them in a while. And there might even be a summary of them in the chapter review. Let me see if there is. No, I don't see a summary of all of them, but. So in this problem right here, x is the 3 to the -2. So this is really -1 times what? 1 over 3 to the second power. What's 3 to the second power? 9. So this is really -1 times 1/9, which is -1/9. What would the difference be between that and this? Big difference? We wouldn't be able to peel that -1 out like we did before, right? The whole thing is raised to -2. So the x that we would have in that property is the whole thing. So I could rewrite this as 1 over negative 3 squared, right? I could do that. Do you agree with that? And what's that? 1/9. This is part of what makes algebra a little bit frustrating, right? Is that, I mean, you're off.
Excuse Sally for pointing us in the wrong direction.
You can go back, yes, that's fine. You go find whoever showed you that and you can get upset with them. But these little things, right? I mean, just these little subtleties in here make the difference between a negative and a positive answer. Which, is that a big deal? Well, potentially, right? If you're building a bridge, right? Something like that. Oops. You think these mistakes don't happen, right? They happen all the time. In fact, one of our first probes that we ever sent to Mars, we lost it. We didn't know what happened to it, and wound up that it impacted Mars and the surface, and we just lost it. Millions of dollars. And it turned out later that the reason why is because there were engineers working on it that were both from Europe and from the United States. And so you know what they forgot to do? They forgot to convert their units. The European engineers were using the metric system, and the U.S. engineers were using the U.S. standard system.
Was it Lockhill and NASA?
I don't know who it was.
I think it was Lockhill
Mm-hmm.
and NASA.
Probably.
Oh, I just learned about that like last period.
Oh, really?
I remember that, yeah.
Interesting. Really?
Because we're talking
kinda
about the
random.
metric system and
Really? They were talking about the Mars thing? Oh, wow. Okay. Well, these things that, you know, oh, oops, no, wrong system.
Isn't that what happened to the Challenger also?
No, I don't know about the real cause of the Challenger. I don't want to speculate. I heard it was a mechanical failure, but. All right, how about this? I think you're ready to go into a little bit more deep material here. How about this? Simplify. Now, this is one of those instructions in a problem that when you see it, you're like, okay, what do you mean simplify? They mean just make it look better than it does right now. And that's very subjective. There was something else I forgot to put up over here that I wanted to show you. We're going to have 3 exams and a final. Last semester, here were the class averages on these. Exam 1, the class average was 73, then 83 on exam 2, 67 on exam 3, and 68 on the final. These are the class averages, just to show you kind of like the first exam was okay, the second exam actually went really well for the class. Third was the worst of all, and then the final. Just so when you're preparing, historically speaking, if you do really, good on the second exam, you're not out of the woods. I mean, like the third exam and the final are the hardest ones. So keep.
If we're going historically, we're screwed. Just kidding.
I'm saying, let me quote Aunt Sally. Here's what Aunt Sally would say. No, you're not. None of this. Look, every class is unique, right? I mean, there's nothing that says you have to follow this, but. The exam 3 historically is the hardest exam. So it is. It's exponentials and logarithms. And that's usually material that students don't do well with. I don't know why. Just it's so foreign. I'm not sure what it is. So you want to try and get yourself ahead of the curve there on the first and second exam. You want to go into that third exam and the final with some momentum. If you're digging up from exam 1 already, you're constantly trying to catch up, kind of like Cleveland last night. If you don't watch basketball, just ignore me. All right, so simplify. This is a disaster, isn't it? What we're trying to do is make this look nicer. If we have x's, we can put them together. If we have y's, try and put them together. If we have z's, put them together. If we have numbers, raised to powers, clean them up. And they like you to never leave an answer with the negative exponent. So we should never have an answer like x to the negative 3. We should never leave that negative. We should always drop it down or something. If it's already down, we want to bring it up. So let's get on a path from point A to B here. Somebody recommend we do something. Go ahead. Okay, so you want to pass the exponents through? Where can I do that? Ariel?
-2 to the 3rd power.
You want to do that now? Negative. Okay, so what would that be? -8. So -2 times -2 times -2 is -8. Everyone agree with that? Okay. Anything else you want me to do while I'm there?
Distribute the y and the z, would that be 1 squared z squared?
Okay, so you want to go ahead and evaluate this, square it. Now, I'm hearing the word distribute, which distribute usually we reserve for something like this, where you have a number multiply and you're trying to multiply it through parentheses. We call that distribution, distributing. Okay. When you have something like a product raised to a power, you're just applying the power to each factor. That's all you're doing. If you understand what you mean by distribute, that's fine. I'm just trying to make sure the language that I use is not confusing with some other operation. So you are allowed to take this 2 and apply it to both of those. What property am I using? You can look in your book. It's this property right here. If you have x times y to the n, you can go x to the n, y to the n. So again, this is one of the properties you should be familiar with. Now, I'm not going to touch the x to the 4th, right? Just leave it alone. And I'm turning this into y squared, z squared. Now, the reason we did that is because we can now free it from this parenthesis, right? Okay, and on the bottom, why don't we square the 3? On. And then everything else, I'm just going to leave. I'm putting these dots between these just to kind of like push everything apart so you can kind of see the things we have in common. Do y'all see them? We've got x's on the top and bottom, y's on the top and bottom, z's on the top and bottom. So how do we combine these together? Can we put these two together? Yeah? Yes? There's got to be some property to put those together, right? So that's really x to the 1st power, right?
Like how many you can cancel out the 2 sets.
Yes, you can do that, like figure out how many you can cancel out, but there's actually a formula for it. Yes? You subtract the exponents, n minus m. The one on top minus the one on bottom. So here I just look at this, x to the 4th over x to the 1st. That's x to the 3rd. 4 minus 1 is 3. Now you could write them out. X, 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 x. There's 4 x's over x and then cancel 1. And of course you get x cubed. But we just want to be able to do it quickly, do the subtraction. So we have -8 on top, x to the 3rd. How about here? Same property, except with y's. So y raised to the -1, right? 2 take away 3 is -1. And then the last one, z squared over z to the 1st, just z. And all of this is over the 9 that was still down there, right? Don't forget there was a 9 down here. And I think we're pretty close to being there, except for I said that the book doesn't like you to leave negative exponents. So we drop that y down to the bottom, and that should be it. So -8x cubed, z is still on top, 9y.
questions that I or other classmates may have answered. Under what circumstances would you be able to cancel out the numbers themselves?
If there's a common factor in both of them, so let's say this was 16, you could have done, 1, which you wouldn't have to write, and then down here this would be a 2, something like that. See, I've got about. Okay, how about this? Different problem. If x is equal to -2 and y is equal to 3, find the square root of x squared plus y squared. So what am I asking for you to do here? Just plug in these values, right, for x. Replace x with -2. Replace y with 3. So the reason I want to give this to you is because I want to ask you especially what's happening with x squared. Like, what am I going to write there?
-2
-2 squared, yes. Now my question is it in parentheses or is it not?
It's in parentheses because you're substituting.
It is because it's being substituted in. That is key. -2 is being substituted in, so it is in the parentheses. But if you look at this and you just came here, right here, and you replace that with -2, would it be in parentheses? It wouldn't, right? So you have to understand that you have to introduce the parentheses. Anytime you're substituting in, it's stuck in a parentheses. Because we know there is a difference between this, right? -2 squared, -2 squared. Those are two different answers. So, everyone clear on what I'm saying? Anytime you substitute something in, always put it in parentheses. And then over here, this one won't matter as much because 3 in parentheses squared is the same thing as 3 without parentheses squared. So there's no difference. So what is this? Square root 4 plus 9 root 13. And we can get on a calculator and figure out what that is, but I'll just leave it like that. The key to the problem, the reason why I gave it to you is to remember that when you substitute something in, it's in parentheses. All right, I want to show you one more thing. There's some stuff in here in your homework with scientific notation. So I'm just going to kind of let you figure that out on your own. If you have trouble with it, just go Google it. Scientific notation isn't something that takes a long time to pick up. It's where you move the decimal point over, it's just, so I'll let you mess with that. I think that what I'm about to show you is a little more important. This is something that always kind of creeps in math classes. You take something like x plus 3 squared. And you ask someone to go ahead and try and expand that out or multiply that out. And a lot of times, the incorrect answer that people will put is x squared plus 9, right? You understand what they're doing, right? Even though that's not correct, you understand what they're doing, yes?
They're trying to square each.
Trying to square each one. So why is it that you can't?
Because that whole thing is the value that you're squaring.
Yes, the whole thing is what I'm squaring. But what I'm trying to do right now, I'm going to try and convince you why you can't just do that. So what we've been told is to do what, like this thing? What do we call that? What do you call it? Do you call it FOIL?
Oil distribution, same thing.
The technical math terminology for it is expanding. Anytime you take a polynomial and you multiply it times another polynomial, it's called expanding. You're expanding the polynomial. If it's 2 terms and 2 terms, you can call it FOIL. But if it's 3 and 7, you call it expansion. All right, so here we go. You do this, you get x squared plus, I'll go slow, 3x plus 3x plus 9. That's x squared plus 6x plus 9. And so the only difference between these two is this 6x, right? That's the only difference. It's like this almost worked, right? But you're missing this much. So what I'm going to show you now is hopefully a way of kind of clarifying in your mind why this is not okay. All right? So let's see if I can show you. You ready? Everyone understand what the answer should be? Everyone understand the value that this is incorrect? Okay, let me see if I can explain. If I draw a rectangle and I say this is the width and this is the length, can you tell me what the area of that is? Is everyone comfortable with what the area of a rectangle is?
Yes.
What is it?
Width.
Length times width, right? Or width times length. It doesn't matter which way you do it, right? So we all agree with that? Okay, so check this out. I'm going to draw a line. Start here at 0. I'm going to measure out. I'm not going to tell you how far it is, okay? Just going to call it x. And then, where'd it go? I'm going to come out here. I'm going to get my ruler, and I'm going to add to that from here to here is x, from here to here is 3. It could be 3 inches, could be 3 feet, could be 3 miles, doesn't matter what it is. So do you all see that from here to here is x? From here to here is 3, yes? Okay, now what I'm going to do is I'm going to draw up vertically the exact same thing. So I'm going to draw this x right here, this way. So there's x. And take my 3, put it up here like this, and there's 3. Got it? Yes? How long is this entire side? 3 plus x, or x plus 3, right? Same thing? So this whole thing is x plus 3. How tall is this entire side? X plus 3. So if I draw from here to here and here to here, that's a square, isn't it? What's the area of that squared? What's the area of this square? This times that, right? So do you agree that the blue here is x plus 3 times itself? Squared? Yes? All right. Almost done. What's the area of that red piece right here?
X squared.
X times x. That's x squared. What's the area of this piece right here?
3 squared, so 9.
3 and 3. Do y'all see it? That's 9. What's the area of this piece and this piece together? X squared plus 9. Do you see that this can't be this?
Yes.
You're missing these two pieces, aren't you? What's this piece? 3. How tall is it? X. This is 3x. How wide? X. Tall? 3. 3x again. Now when you put all of them together, you get x squared plus 6x plus 9. Yes? That's a visual way of seeing why you can't do this.
I've never seen it drawn like that.
Yeah, I hope it makes sense, but all right.
Interesting way to remember it.
Well, the biggest thing I'm trying to get you to do is just realize you can never do that. You can never just square each one. And what made me think of it is that we just did that a second ago when we had x was it z or yz squared? I think we had yz squared, and didn't I just do the 2 on both?
Yes.
Well, the difference is that this is multiplication. If this is addition, you can't do it. If it's subtraction, you can't do it. It must be multiplication for you to be able to just drop the 2 down to each one.
So if there's an addition, everything there's
You can't do it. You have to expand it, and then you can start messing with it. All right, so what's the assignment for tonight? Because we're pretty much out of time. Oh, I forgot to do the sign-in sheet. Did I? No? Did it go around?
You did not do this.
Where is it?
You're supposed to do the assignment by Thursday.
There it is. Quickly. Initial next, down this first column is today's date. Initial next to your name, pass it around. Okay, so for next class, the assessment, right? The assessment exam, come in with, or assessment exam, the assessment, bring it in. You're not going to be graded like a test on it, all right? Bring it in, and you'll be pulled out of class, and then whatever happens, happens, okay? And then try and do the homework, and we'll come back on Thursday. And
For a quiz grade, that's just if we do it?
what's that, the assessment?
Yeah.
It's a quiz grade, yes. Yeah, yeah.
So this is the first year y'all are having the two people go ahead and counsel?
No, it's the second semester, but it's the first time we've had like a place where you can go to like drop the class, add you to a new class, take care of anything financial aid wise, reimbursements. That's all there, but it's the second semester where they've actually pulled people out of the room that I'm aware of.
That's really neat thing y'all got
Yeah,
there.
yeah. Okay, everyone. Have a good day. Sorry, I forgot. Next time, remind me, I'll get that sign-in sheet passing around earlier. Did you have a question, Ryan?
Where are we
Sandra,
going to be able to find
don't
these
forget your
videos?
thingy here. Y'all don't forget, take these home with you and put them in your,
Where are we going to be able to find the videos that are recorded?
on our webs,